Hey, this is Horner. We're going to look at the last part of the electrostatics notes, and we're going to talk a little bit about a law called Coulomb's law. We know that if I have two protons, those two protons will repel each other, and they repel each other with a certain amount of force, and so those forces are equal and opposite. Same thing with two electrons or two negatively charged particles, and then a positive and a negatively charged particle will actually pull each other together. So there are forces here. And if we remember, we also said that there was a force between two planets, and we called that Newton's law of universal gravitation, and we looked at those. So Coulomb's law is very, very similar to that in that the force is proportional to 1 over the distance between the two. So when we look at the equation that you see here, there's several things. This is the electrostatic force. K is a value that tells us the constant. It's called the electrostatic constant, and it's a very large number. It's about 9 times 10 to the ninth. The Q's are both charges, so usually you have two things that are charged and they each have their own charge, and then R is the difference between the two. Now, like we said, this formula is very similar to the formula that we use for the force between two objects in terms of gravity. And we said that that was big G times the mass of the first object times the mass of the second, all over the distance between them squared. But remember, G was really small. It was 6.67 times 10 to the negative 11th. So that tells us that gravity is actually a very weak force and that this electrostatic force is very, very strong. Let's go ahead and take a look now at a couple of charges here. So here is here's the first charge. It's a little bit bigger than our second charge. So Q1 and Q2 would be the values for each one. K was our constant again, and then R is the distance between them. So let's go ahead and try to solve for the first one. First question. It says 3 protons are separated by a single electron at a distance of 1 times 10 negative 6 meters. Find the electrostatic force between them. Is it attractive or repulsive? So if we have 3 protons together, so we're going to say that these protons are together, and we have a single electron, and let's make the electron blue, so we'll just move it over here. Oops, I meant to choose blue and it didn't go. There we go. So now we've got a blue electron. There is a force between those, and we know that since they are opposites, they actually will be attractive towards each other. So we have 3 protons, we have 1 electron, and that is definitely an attractive force. So now we have that out of the way. Let's go ahead and solve for this problem. First thing we need to do is think about the charge on these 3 protons. So I've got 3 protons, and like we said before, we've got to figure out what the charge is. So I know that one proton has a charge of about 1.6 times 10 to the negative 19th coulombs. And so when I multiply 3 times the 1.6 times 10 to the negative 19th, I get 4.8 times 10 to the negative 19th coulombs. We also need to figure out what is the charge on the electron, and because there's only one, we know that that one's negative 1.6 times 10 to the negative 19th coulombs. So now I have my two charges. Now I can use my equation. So the force, electrostatic force between the two, is 9 times 10 to the ninth. A lot easier to write than the 8.99. And now we've got to put in both of our charges. So this first one was 4.8 times 10 to the negative 19th. And the second one is negative 1.6 times 10 to the negative 19th. And we're going to divide them by the distance between them. And it said that the distance was 1 times 10 to the negative 6 meters. When we're done, we should end up with negative 6.9 times 10 to the negative 16th newtons, and that is definitely an attractive force. For the next problem, it's question number 9. It says a distance of 1 meter separates the two centers of two small objects. The spheres exert a gravitational force, Fe, an electrostatic force, well, this should be Fg, and a electrostatic force Fe on each other. If the distance between the spheres is increased to 3 meters, the gravitational force and electric force, respectively, may be represented as, now notice the only thing that they gave us were the distances. And we remember that the force, either gravitational or electrical, is equal to 1 over the square of the distances. So if we're going to increase this by 3, that'd be 1 over 3 squared, which is going to be 1 over 9. So they will both can be represented by letter A, which is Fg over 9 and Fe over 9. We know the charges don't change from what it says. We know the masses don't change. The K and the big G value don't change. So the only thing that changes is the radii. So we know that they're both 1/9. So kind of a nice little trick question for you. Number 10 says the centers of two small charged particles are separated by a distance of 1.2 times 10 to the negative fourth meters. The charges on the particles, they give us two charges. Calculate the magnitude of the electrostatic force. So this part's pretty easy. We know it's just Fe is equal to K times Q1 times Q2 all over R squared or D squared. You can use either one. So this is 9 times 10 to the 9th times 8 times 10 to the negative 19th. You'll notice I'm using E here instead of times 10 because sometimes they do that. And then our last charge is 4 times 10 to the negative 19th. And we're going to divide that by the distance between them, which is 1.2 times 10 to the negative fourth. And that quantity is squared, so be careful that you square that. And we find out that the electrostatic force between the two is 2.4 times 10 to the negative 19th newtons. The last thing that they want us to do here is sketch a graph of the relationship between the magnitude of the electrostatic force between the particles and the distances between the centers of the particles. So I go ahead and do this. I'm going to say this is the magnitude of the electrostatic force, and then this is the distance between the centers. And our graph should end up looking like this because we know that it is a 1 over the square is our relationship. So remember Fe is proportional to 1 over the square of the distance between the two. And that is the last part of our discussion on electrostatics.